this is our lesson 5 on von Neumann architecture. This is lesson 5 of computer systems. We are following the GCSE computer science OCR specification J277. So before we move on to von Neumann architecture, we need to understand who was he, why do we follow it? Okay. The von Neumann architecture is the design upon which many general purpose computers are based. So what is a general purpose computer? A general purpose computer is a processor, a memory unit, and secondary storage. That is a general purpose computer. So what is the von Neumann architecture? Now, as we all know, von Neumann was a mathematician, which most general purpose computers are built upon. The von Neumann architecture outlines how the computer memory, input-output devices, and processors all work together. We will also be looking at the 4 main registers: the program counter, the memory address register, the memory data register, and the accumulator. So what is the purpose of program counter? Program counter holds the address of the next instruction to be executed by the processor. What does MAR do? Holds the address of where the data is to be fetched or stored. What does memory data register do? That basically it holds the data that are read from or written to the main memory. And the accumulator is just stores all your calculations. What are buses? Now remember, these are not our buses which are on the road. These are buses which run around, which are like cables or wires, which transport data between the components inside the processor and memory. What are the characteristics of buses? They manage the flow of data around the CPU. So let's understand how these registers work in action. So, first of all, say for example, I've switched on my computer, and the first thing what it does, it starts the fetch, decode, execute cycle. That's the first thing happens. So I have set to the computer add 8 plus 2. So what will happen? As you can see, the program counter is on 0. That program count, that instruction is copied over to MAR. Okay? MAR, then that instruction goes via the address bus to the memory location and data. So I have said to 8 plus 2. So I will say load, and I can put that here and put a 2 here. Okay. So load 3. So I'm saying load 3. So what is going to happen? That loading of 3, which is 8, will be copied via our data bus. Now, why is it called data bus? Because it is carrying your data. It will be carried by data bus and it will be copied into MDR. So now what happens? The data 8 is copied into MDR. What is the role of what will happen next? There is another register called CIR. Now CIR will hold that data here. It's holding that data till the control unit, who's the main boss, decides where that instruction will go. Obviously, as it's a mathematical instruction, it will go into ALU. So it has fetched and decoded. Okay? It has fetched and decoded. Now, what is going to happen? Now, I've asked it to add 2. So what? Again, the program counter increases to 1 now. that instruction is copied to MAR. Okay, it goes via the address bus. It is, so here I can say add. What do I add? What is in memory location 4? So I will say load 4. So what is going to happen? That instruction will be copied now into MDR, because what I am saying is add 2. So what is where is 2? 2. So it's saying load 4. So where is 2? It's in memory location 4. So it will load 2 now. Now CRER is now holding 2. So again, so here it is decoding. Basically, it's decoded that. Now the control unit will decide that 2, which has been decoded or as stored or is held, anything you can say, will decide where that 2 goes. That 2 will go here in ALU because it's another mathematical calculation. But what have I asked it to do is to add. So what will happen? 8 will be added to 2 and it will be stored in the accumulator. So what is the job of the accumulator? It stores your calculation. That's what it has done. So let's look at our next slide where you can see how it is working. This is just a simulation, how you input, how your registers come into being, and how it goes to it's executed. So let's look at the steps. An input device such as the keyboard sends data to the CPU. The control unit receives the data. So what did I do here? If you look here, I said add 8 plus 2. So how did I do that? I did it via the keyboard. That's what it does. Sends data to the CPU. The control unit receives the data. So what did happen? Here, the control unit decides what to do. The control unit sends the data into main memory to be used later. When the time is right, the data will be transferred from main memory into cache. Now, we will talk about cache later in a detailed video where you understand what is the role of cache. The data will then be sent to the ALU for processing. The control unit will send the processed data back to an output device such as a screen or printer. So let's recap. The von Neumann architecture consists of control unit, ALU, RAM, input and outputs. And what are the registers? The registers are program counter, MAR, MDR, accumulator. There are more registers, but we need to be aware of these for our GCSE. So let's look at an exam question. It says here, complete the table by writing the missing definitions or name of each of the components, common CPU components and register. So answer is this. Okay. So stores the address of the next instruction to be fetched from memory, increments during each fetch execute cycle. That's the program counter. Control unit is basically the main boss. It coordinates the process and everything what is happening in the CPU. It does everything. It decides what to do. MAR stores the address of the data to be fetched from or the address where the data is to be stored. And ALU, we all know that, does your maths and logical operations. Let's look at another question. Alicia has designed a computer using von Neumann architecture. Describe the purpose of 2 registers that are used by von Neumann architecture. So you could have spoken about any 2. So let's just look at the last 2 ones, which are which I can read out. Program counter stores the address location of the next instruction to be run, and accumulator stores the result of manipulation, process, and calculation.